Hey there, AB students. In this video, I'm going to show you two examples of tangent line approximation. So here we go. Let me do this problem down here, number 6. So we're supposed to approximate 2.99 cubed using the tangent line to the curve y equals x cubed at x equals 3. So the first step, what is our function here? So the function here is fx is equal to x cubed. The next step is what is its derivative? So f prime of x is equal to 3x squared. That's just the power rule. And the next step is we need to come up with the equation for the tangent line to the curve at x equals 3. So this should be, the equation should be something like y equals y1 plus mx minus x1. So first of all, what is the m? M is a slope, which you know is derivative. So m here should be the derivative when you plug in 3 into it. So if I plug in 3 for x into this derivative, I get 27. x1 is the point that you're given, that's 3. And how about y1? What is y1? So y1 should be the y value when x is equal to 3, which is 3 cubed, which also just happens to be 27. So that means our equation for the tangent line is going to be y equals 27 plus 27 x minus 3. So there's my equation for the tangent line. This right here is the equation of the tangent line. The next step is I want to approximate the function at 2.99. So I just plug in 2.99 for x. So I have that y when x is equal to 2.99 should be 27 plus 27 times 2.99 minus 3, which is, let's see, 27 plus 27 times negative 0.01, which is 73. So that's my approximation to 2.99. Now a follow-up question you might ask is, you want to ask, is this approximation an over or underestimate of the truth? So let me do that right here. I want to ask, is this an over or under approximation of the truth? So think about the function. So the function is fx is equal to x cubed. This function, if you graph it, it looks something like this. Here's the point when x is 3, y is 27, it's someplace up here. Notice that this function is concave up. Another way to see that is if I take the second derivative, here's the first derivative, if I take the second derivative, then I get f double prime of x is equal to 6x, and in particular f double prime of 3 is equal to 18, which is bigger than 0. That means the function is concave up. If the function is concave up, that means the tangent line, here it is, tangent line to the curve, actually lies beneath the curve. So because it's concave up, that means tangent line lies beneath curve. And this means that your approximation will be an under approximation. Okay, now I have one more problem to show you. It's on this page. Let's try the first one on this page. So here you're given the function 1 plus tan x to the power 1.5. First we want to write down an equation for the tangent line at x equals 0. So anytime you see equation of tangent line, think derivative. So first we should take the derivative. This function, there's a outside function, which is to the power, outside function is It's kind of like u to the power 1.5. And the inside function is u is equal to 1 plus tan x. So when I take the derivative, I will need a chain rule. The derivative should equal 1.5 times 1 plus tan x to the power of 0.5 times derivative of the inside function, which is, let's see, derivative of 1 is 0, derivative of tangent x is secant squared x. Now the special point I'm interested in is x equals 0, so I should plug in 0. So f prime of 0 is equal to this thing, 1.5, 1 plus tan 0 to the 0.5 times secant squared of 0. Tangent 0 is just 0. Secant of 0 is 1 over cosine of 0, which is 1. So this whole term is 1. So I just get out of here 1.5. So for the tangent line, I will use y is equal to y1 plus m x minus x1. x1 should be equal to 0. That's a special point you're given. M we just calculated as 1.5. And y1 should be what I get when I plug 0 into the original function. When I plug 0 in here, I'll just have 1 plus 0 to the power 1.5, which is just 1. So that means your tangent line will be y is equal to 1 plus 1.5 times x minus 0. So there is the equation of the tangent line at x equals 0. Okay, part B. Using the equation found in part A, approximate f of 0.02. So what we'll do is we'll just plug in x is equal to 0.02 into the tangent line. And this will be our approximation. So y of 0.02, I'm just going to plug 0.02 into the tangent line, be 1 plus 1.5 times 0.02, which is 1 plus 0.03, which is 1.03. So this was 2 examples of tangent line approximation. There's not that many steps. First, find the equation of the tangent line, plug in the point that you're trying to approximate, and then finally use concavity to determine if your approximation is over or under the truth.